Hi guys, Ms. Malik here again. Today we're going to look at some of the symmetry properties of the unit circle, but first I just wanted to finish off 6b. We forgot to talk about tan, so we'll do that now. Here is the unit circle. Of course, the radius is 1 unit, and we have cos theta, which is the length of the x value there, and sine theta, which is our y value. Now, if we are to extend the line on the x right out to the edge of the circle, and then extend to make a triangle like shown here in red, we say that tan theta is the tangent to the circle there. So it's that line that sits on the edge of the circle and makes a triangle with the outside of the circle. Tan theta is therefore sine theta over cos theta, and of course if the denominator is 0, the solution will be undefined. So if your cos theta is a 0, then tan is going to be undefined. Let's just see how we go about using CAS to evaluate tans. So if we have tan 1.3, we just enter it into the calculator. We want to make sure it's in radians and that our answer is in decimals, because our question is asked in decimals and it's in radians. So tan 1.3, tan 1.9 and tan negative 2.8, and you can see there on the calculator screen that's what we'll get: 3.60, negative 2.93 and 0.36. Let's see now tan 59 degrees, tan 138 degrees and tan 250 degrees. So now we've got the degrees sign there. So you want to make sure that now you're in degrees. So down there you can see it circled, and again we'll have it in decimals, our solution. So tan 59, tan 138 and tan 250, giving us 1.66, negative 0.90 and 2.75 respectively. Let's now move on to the symmetry properties of the unit circle. I've got the unit circle drawn here, and this time I've drawn a line to make theta, and I've taken that right through the diameter of the circle there. So I'm going to call that point there P. So P at theta is cos theta sine theta. So they're the coordinates of that point. I'm going to call that AB. I'm now going to draw a line across, and in the middle there you see point 0B. It's B because the sine value is still the same. Look at point P where we have theta. So you can see that the x value is cos theta and the y value is sine theta. Because I'm moving horizontally across, I'm not changing my y value. So my y value stays the same. So I'm going to continue to call that B as I did for point P, and 0 for cos, because, or for my x value, because, well, look where the point is. It's on the y-axis, so it's a y-axis intercept, or similar to, so we call it 0b. Let's put another point. This is P of pi minus theta. Let's think about that. So pi would be this point here. So halfway around the circle, because the diameter of the circle would be 2 pi, because 2 pi r and the radius is 1 unit. And so pi would be half the circle, as we already know. If we subtract theta, so let's put theta, we see it here, and then if we put it over in this area here, that's pi minus theta is the angle made from 0 all the way around to here. We'll then call that point pi minus theta. Let's move down. We have negative a and 0 for this point here. So let's think about why that would be. If a is our cos value and b is our sine theta of point P, then, well, we're on the x-axis, meaning that our y value would be 0, and negative a because we've made the same angle, and the radius of the circle is 1 unit all the way around, of course. Down here we have the point P of pi plus theta. So now we have the angle theta in here. And here's another point here of 0 minus b. Of course it's minus b because up here is positive b, which is our sine value. And then down here is negative b. And over here, this is 2 pi minus theta. So now we're putting theta into here. 2 pi would be all the way around, we minus theta to get to there. Then back up, let's connect up our rectangle of A0 will be here, A being our cost value, because it is vertically in the same place as our point P theta, and 0 because we're not moving off the x there. We call this quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Notice how we move in an anti-clockwise direction as we go around the circle. Now, another useful thing to remember is that in the first quadrant, all your sine, cos and tan values will be positive. So you see in quadrant 1 I've got an A, and that's because all are positive, A for all. In the second quadrant I've got an S. This is because sine is positive. Cos is negative, so therefore tan has to be negative as well, because tan is dependent on sine and cosine. So if one of those is negative, then, well, you're going to get a negative tan as well. In the third quadrant, tan is positive. Think about it. In the third quadrant, if you've got your cos values or x values being negative and your y values being negative, negative divided by negative is positive. So tan must be positive in the third quadrant. And last of all, in the fourth quadrant, we've got cos being positive because your x values will be positive, whereas your y values will be negative. So therefore, you've got one negative and one positive, making tan negative as well. Okay, now moving on, here we have our unit circle again, and here are all the points that we talked about in the beginning. Now, the question that we're given is, if sine theta equals 0.5 and cos alpha equals 0.6, find sine pi minus theta and cos 2 pi minus alpha. Okay, so let's think about this. Here we have point theta, where we have our value of cos theta and sine theta being our x and y values respectively. Now, when we move over to pi minus theta, that's over here, highlighted there. It's pi minus theta, as we said, because pi is all the way around to the halfway mark, and then theta would be in here, and we're subtracting that, so we get this angle here. So sine pi minus theta is going to equal 0.5 also, because your sine value is going to be the same. Remember that the sine value is your b value, like we said here, and it's the y value. So if we're going over straight across here horizontally, your y value does not change. So therefore, if sine theta equals 0.5, then sine pi minus theta is also going to equal 0.5. What about 2 pi minus alpha? So we know that cos alpha is 0.6. So if we were to put, instead of theta there, if we put alpha, then cos alpha would be the length of 0.6. Now let's go around to here. So we subtract our angle. So we put it there and we've got this point there. So the point at 2 pi minus theta means we're still going to have a positive cos value there. So it's still going to give us the cos value the same as at the point where we've got theta there, or alpha if you want to call it alpha. So if cos alpha is 0.6, 2 pi minus alpha, cos 2 pi minus alpha is also going to be 0.6. The next part is where we want to find two values of x in the range of 0 to 360 degrees. For sine x degrees equals negative 0.3. So they're saying to us, what two angles will give us a length for sine of negative 0.3? First of all, let's think about where sine will be negative. So sine is our y value, so it must be in quadrant 3 and quadrant 4. I'm now going to work out what x would actually be. So I'm going to use my CAS to solve for x there. and x is going to equal 17.46. So that means that I've got an angle of 17.46 in here. And that's going to give me 17.46 in here. So that's what that would look like if I had that angle. Now, that would be a positive sine value. If I were to connect up my points there, and I would have a positive sine value. So I want to take that angle and I want to put it into the third and fourth quadrant, because I know that that's where I'm going to get a negative sine value. So first of all, I'm going to put it into quadrant 3. And as you can see, if I was to go all the way around the circle from 0 all the way around to my pi plus 17.46, that's the angle I'm talking about. So I can get negative 0.3. Because we're dealing with degrees instead of radians, I'm going to have to say what would be, how many degrees would it be to get from 0 to pi? Well, it makes a straight line, so it's going to be 180 degrees. It's halfway around the circle. So it's going to be 180 degrees plus whatever this angle is here. And as we know, that's 17.46. So to get to, to get to here, I've got 180 plus 17.46, which gives me 197.46. So one of the angles where sine of that angle equals negative 0.3 is going to be sine 197.46 is going to give me a value of negative 0.3. My length here, or my sine value here, is going to be negative 0.3. Let's now go over here. So I'm going to take it into the fourth quadrant where sine is negative again. I'm going to put 17.46 in there. Now it's going to be all the way around the circle except for that part. So I could say 180 plus 90 plus whatever that would be in here, the complement of 17.46. That's a lot of effort. Why not just say it's 360 degrees all the way around the circle minus that angle? And we know that angle is 17.46. I want to get to that star. Let's see. 360 minus 17.46. It equals 342.54. So what that's telling me is that sine 342.54 degrees is going to give me a length for sine of negative 0.3. Now, let's try this. Let's try for cos x equals negative 0.7. Once again, I'm going to find out what x would be in that case. It's going to be 45.57. Okay, now, if I've got an angle of 45.57, let's say that it's here. My cos value, or my x value, would be positive. We don't want that. We want a negative length of 0.7. So here, where I've drawn it, at 45.57, I have a positive 0.7 length of my x value. Where do I have a negative? Well, if I put it into the second quadrant or the third quadrant, my x value or cos value is going to be negative, and that's what we want. So let's see what that's going to be. Let's go from 0 over to here. We know that in here it's going to be 45.57, so it's going to be 180 minus 45.57. That gives me 134.43. Next, let's go in quadrant 3. Here's 45.57 in here. It's going to be 180 plus 45.57 to get all the way around. That gives me 225.57. And that's it. That tells us the basic symmetry properties of the unit circle. We'll do some more symmetry properties in the next slideshow.